Hello everyone, and welcome back to a new episode of EXAPUNKS. We just finished murdering a friendly Exa who was just trying to hang on to a file, and we took it from him. So we learned how that works. Restore a file from an antiquated backup system. So they mentioned a tape backup in the manual. There's another file I want to grab. They tried to wipe everything clean, but luckily there's a set of backups. Always keep a backup, right? Yeah, sure. You never know what's going to happen. Data is more fragile than people think. The UC Berkeley tape backups. Okay. Locate the specified host, either tape 1, 2, or 3, and then locate the specified entry in the tape backup file in that host. Ah, here, look, there's a loop. Oh, no, there's not. Because all of these are one-way doors. Right. So there's a loop, I guess, but -1 is still always clear. Okay, create a file. The names of the hosts. So how do we know what host we're in? Accessing data and legacy storage systems. So I guess we're reading through the manual, and I'll try not to forget you guys there. Manual. Look at the table of contents. Page 26. We passed it. Here we are. Tape storage systems. One host per tape unit. Tape mounted as a file that can be read. Each tape contains 0 or more entries. The data starts at the beginning sequentially. Impossible to tell which data belongs to which entry. Metadata is at the end of file. First value. Okay. So hard drive arrays are a different thing from tape file storage systems. Here's an example. It's like some stuff. And then at the end is the metadata. So we have to skip to the end, read backwards by 3, see if it's the thing we want. If not, read backwards by like 4, I guess. Okay, but how do I know which host? Was there something in the language reference on page 14 about looking up the host you're in? Copy, add, swizz, mark, jump. Test host. Aha! Copy the name of the current host into the specified register. Got it. Now, here's the thing though. How can I tell I need to exit? Or that I want to exit? This like 243 marker is the only way I could tell, right? Well, or the link -1, but in that case... I guess I could I could know how many steps away I am, like tracking how, because you have to walk forward exactly 8 times to traverse this whole loop. And so if you track how many times you've walked forward, then after you've read the data you wanted, and okay, so create a file in your host containing that entry's data. Oh, we don't need to get out, actually. We can just send one EXA in and have it transmit the data it wants back over the global communication network. Let me show you guys the game. I remembered before doing anything too interesting. Yeah, so you have to do exactly 8 steps around, which would be important if we needed to return, but we don't. Although, I guess I need to transmit the length of the sequence back to this guy, as well as how many, as all of the bytes themselves. But that's fine. The length is in this thing anyway, right? So, okay, so this is exciting. We want to what? Make a new EXA, and can I like rename them? What did that button do? I have no idea. Oh, I can put them over here? Why would I want that? I was just hoping to give it a name. Oh, I can. We'll call this one the Explorer. Oh, I only get 2 letters. Okay, well, never mind. EX then. So your job is going to be the following. To link 800. We'll call this search. And I guess we'll move the copy, put this before the search. Copy from M into X, please. That's where we're going to store the host name we're looking for. XA will be grabbing 300, move F to M, and then move F to M again when this guy's ready to have it. And finally, we'll just wipe this file. Who needs it? Make a new file, and then we'll receive instructions from this guy about what to do with that file. So this guy's job is going to be host into T, I guess. Test T equal F. And if not, F jump back to search. Does that sound about right? That's going to get us to the place we want to go? What is my error? It's not move, it's copy. I am never going to get over this. Copy. Copy. He died. What did I do wrong? Oh, not F. X. So we want to go to tape 3, right? And he's going to keep going until he gets there. They are the same, so he doesn't jump to search and he just dies. Great. So once he has arrived there, he will wish to copy from M into X. He no longer cares what host he's looking for, and now he needs to know what secret key he's looking for, right? Having done this, he will now grab the file that he is interested in, 200, and seek the end of it. And we will now begin the scanning loop. And I'm just going to run this so far so I can see exactly where does he seek to here. Okay, so past the end of the file. Fine. So we need to seek -1, 2, 3 to get to the data we're looking for. Although, maybe it would be better to have that be here. No, here's right. Right, because we're gonna read this value and be pointing here, and then we're gonna need to go back 1, 2, 3, 4. Yeah, so maybe we'll just do this, and then seek -4s at each of these steps. Okay. So now we want to test whether f is equal to x. And then seek backwards by -4, assuming again that it was incorrect. And f jump back to scan. So how would I, if I wanted this guy, okay. This is toggled like permanently. Is there like a command to change the mode or something? Because that might be interesting. There is, yes, toggle the M register. Because I was thinking that the amount of, okay, let me go refresh myself on, the amount of data we need to hold might be too much to fit in all these registers is what I'm saying. Let me go refresh myself on how the tape system format works. So, beginning of the file, skip the first N, and then read that many. I guess I can read a value into T and into X, and that's enough. And then I can seek to the beginning and then seek forward by one of them and then read X many times. I guess that fits in one pot. Okay. So here we are. We have now hopefully succeeded in finding the value that we wanted, except we wish to now undo a seek of -4. Now we are pointing at the value we want, and we will copy the offset from F into X and copy the size from F into T. And then we should be about ready to start transmitting, right? Copy X into, no, not X, but T into M, so the other guy knows how many things to expect. Should never be equal to 0 here. So I guess we're gonna seek to the beginning of time. That's 8, so I guess we use 9s. And then seek forward by X. Begin reading. Now, how do we read exactly? We copy from F to M. And then it's just like not super convenient to subtract and then jump. Like these loops based on the value of t with no testing are a little bit inconvenient in this language. So right, t is how many things we still need to read. We absolutely need to decrement it by 1 at some point, I guess. But the problem is that now the value in t is negative when we wish to stop instead of being 0 when we wish to stop. So I think that what we need to do is before we need here a read loop, mark read, right? And I think we need to just add 1 to t to make everything simpler, right? In fact, we could do that before we transmit it, because the other guy's going to have a similar problem, right? Oh, I copied the wrong thing. I want this. Okay, we're going to send him a number 1 larger than the number of values we wish for him to read, because that's just like the easiest thing. Now we can sub 1 and, or wait, do we want it to be 1 larger or 1 smaller? So if we wanted to read, say, 3 things, no. What's in T is 1 more than the number of things left to read, right? So if the number of things left to read is 0, then T will be 1, which means that after we subtract 1 from T, it will be 0. So we just want to F jump. No. T jump back to read. And otherwise we can just halt. We just have nothing left to do, right? So meanwhile this guy will copy from M into T, and then begin a mark right loop, let's say. Where he will copy M to F, sub 1 from T, and T jump back to right, and otherwise just sort of die, right? Let's see what happens. You get over to the correct host, now we're picking up the file, searching to the end, right? Yes. And then we search backwards for this weird Russian stuff. We looked and, oh look, we found it. So we're gonna not jump, seek forward to the values we wanted, copy them into X and T, add 1 to T because reasons, and send T to M. Go back to the beginning of the file, and then forward by X. And then we're going to copy a bunch of things. Right, the copying should be pretty straightforward. It's just the boundary condition I'm interested in. Okay, we copied 1 too many here. Really? Maybe we didn't need to do this add at all? Yeah, I guess that makes sense. Value in T is how many left to read, including the current round. And then after we subtract 1 from that, it's not including the current round. So when it's 0, it means we should not continue. Okay. So here we go, copying all this stuff. We just copied that. We're subtracting. We're out of instructions. We did it! Not bad. A pretty normal solution, it looks like. Could have done... A few people found slightly faster solutions, which is interesting, but not that important, really. Kind of a shame what happened here. There was some interesting research going on. Yeah, I don't care. This network is a place where I used to hang out, that's all. Yeah, not suspicious at all. Ooh, I guess we'll try another one. Win a game. Oh, optional. This is solitaire. Like they had the solitaire thing in the last one. All right, let's see what this whole game is all about. Testbed, whatever games, sure. Sometimes picky. Well, this one's fun. Oh my god, it's more friggin' solitaire. The old Neckberhick. I don't recognize Russian characters very well, so. Instructions. Is this just literally normal solitaire? No. Face cards? Well, but I don't care about solitaire. I'm not here to play solitaire, so get me out of here. How do I quit? Okay. Take delivery of more medication. A cutscene.
Special delivery.
Like
whatever it is you're doing for money, it's working. Makes me wish I had a line like that. More control over my life. I found out something interesting the other day. You ever hear about these things called X's? They're these little guys running around inside computers. They make it all work. Banks, commerce, government, anything you can think of. Funny. How it's all based on the same stuff on the inside. Just something I've been thinking about lately. Anyway, see you around. Got a feeling I'll be making more deliveries.
Weirdly talkative for a delivery person. Workhouse. Modify the workhouse database so Ember 2's activity is less suspicious. I don't like these workhouse guys. They tried to make me into a mechanical Turk. How many receipts do you think a normal human being could enter per minute, assuming average conditions? Let's see. Entering a receipt per minute. I mean, given the receipt, they gave us 1 receipt to work on, right? And it was like, probably less than a minute. Maybe a minute. About 1. I guess she's been entering way too many receipts and people are noticing. So now we're inside the database of easy work for easy money. Very good. Locate Ember 2's user file in the user's host. And overwrite it so that the sum of the values is the same, but no individual value exceeds 75. All values except for the last must be the maximum value, 75. You will need to add additional values to accomplish this. Ember 2's username is available in file 300. Note that the sum of the values will always be less than 10,000, so you don't have to worry about like clamping and stuff. For more information, see Workhorse in the first issue of the zine. So what is this? There's a secure area here. Alright, well I guess we'll go look at the zine. Here we are, on the right page already even. If you ever need money, blah blah blah. User database. First there's a user's host. It contains a file for each account. Log of how much money they made. Use this as a tracking system. Jobs, currently active jobs. tasks. Sounds like I don't need any of that stuff. I just need the user database, right? Find them in the user's host. Okay, so there's a separate file for each user? Is that correct? What is this? Okay, this is telling me what file corresponds to a username and also some other thing. A user's name, date of birth. Okay, this is not totally explained in the manual, but normal human. Username is there. So file 273 is over here in jobs. We don't care about this. These all have exactly one entry each, and this secure thing has the file like 249 for normal human, links to norm standard, I guess. And apparently this is someone's passwords. Yeah, very funny. Workhorse 252, let's just confirm this, points to, I don't know, it's a file. So I guess we're gonna go up here, scan this file for telling me which file to get. Which file to read and modify, right? Yeah, she's been making a lot of money. Okay, so I guess the thing to do is hang on, how do I know when I'm done reading a file? Like, one way to find out is your Exa explodes, but that's inconvenient. It's like, obviously what we want to do is sum up all of the entries in the file, delete all the existing entries, and then write enough 75s plus whatever is left over to fill the file, right? And exactly how to do that, like, it's not clear, right? You could do modular arithmetic and like just figure out how many 75s and what the remainder is, but that's like kind of taking up a lot of space. It might be easier to just say, here's the number I need to write. Is it larger than 75? If so, write 75. Otherwise, write the number. That's probably simpler. But the trick is like reading the file. There was no way to see what position you're at in the file, right? I remember looking for that and I just didn't find it as far as I know. Yeah. Ah, test EOF. If you are at the end of the file, it sets T to 1, otherwise sets it to 0. Okay. Got it. So, I guess, do we need 2 X's? Still sort of unclear. Let's try doing everything with 1, and if we need another, we can make it, right? So let's grab 300, copy F into X, not coy, drop the file, link 800, grab 199, and now we need to scan through the file for that user, right? So test whether F is equal to X, user, we'll just call this file, and seek forward by 2. And if they are not equal, then jump backwards, forward, no, jump to the file indicator. Yes, very good. Otherwise, drop that and go over link 799. Let's just make sure we have done this correctly. No, we don't want to drop it in that case, right? We want to seek backwards by 1 and copy F into X. Now we have the user number, right? So let's the correct file. So let's grab X. Now we're going back. We've got file 249, and we said now picked up the correct file. Very good. So what next? We want to seek forward by 2, ignoring these 2 values. Move 0, not move, copy 0 into X, so our sum is empty, and then begin the summing process. So let's have a mark here where we mark sum, I guess. First thing we'll do is I guess we don't need to test for EOF here, huh? Let's just add I, xf, storing it in X, seek backwards by 1, and delete that entry. Now test whether we're at end of file, and if not, jump backwards to sum. If so, we are at the end of the file and we have our total. Is that correct? Tested. Correct. Okay, good. So now we have the sum. And let's just mark payout. Pay, we're paying here. And what exactly is the process? It is to we'll just do something simple. Test whether X is greater than 75. If not, then jump to done. If so, well, we can make this a bit faster, right? We'll we'll assume the total is always at least 75, right? So let's copy 75 to F. Sub I and X 75 75, storing the result in X, and if the result is greater than 75, we'll just go back to this pay step, right? Test X greater than 75. True jump to pay. Otherwise, all values except for the last must be the maximum value. Does that mean the last must not be maximum, in which case it should be 0? I'm thinking no. Probably it should be, if it divides 75 evenly, we should stop at this point. We'll just try first copy X into F and see what they think about that. So we're adding up the total here. Now we have our total, and we're going to write out a bunch of 75s. Oh my gosh, it takes forever. Is there a way to set breakpoints or something? I don't see one. Well, we'll just say play. That's certainly faster. Pause. Oh, nice, I nailed it. Test whether it's greater than 75. It was not. Therefore, we just write it and we leave. So that was complete. Did they give me any where it's visible by 75? They didn't, so I don't have to worry about that. Okay. So a few substantially better cycles approaches, but all pretty hard to come up with, apparently. Interesting. What could we have done differently? We could have done the division once. Storing the result in T. And then not needed a test, I guess? Yeah, that might be better. We can do that, right? So here we are in pay. We'll just div I X by 75, storing the result in T. And subtract 1 from T, storing the result in T. And then we will just, instead of a copy, we'll div I X. No. I can't type. Mod I X by 75 into F. Right? Yeah, that seems good. Hang on, one of these is stuck. We wrote a 0 this time. Last time we didn't make that mistake, but this time we did. So this is, so test run 8 is the problem, right? And the goal is just to not have that 0. So that's easy enough to fix, but I thought we would have had that problem last time, right? So we can store the result in X, that's no problem. Or in T, even. And if that result is false, we'll just F jump to end. Copy T into F, our end here. Yeah. So this was fewer cycles. Although apparently not the optimization people usually found. There must have been some way to do this without quite so many unnecessary reads, but whatever. Just when I think I'm decent at pretending to be human, I find there's another parameter to add. Thought the AI would be way faster. Not fast enough for you, huh? I'm not magically good at everything, you know. We could always go back to you doing it. Let's continue. Okay. Well, that is enough for this episode. Next time, I guess we'll be breaking into a bank. Thanks for watching, and I'll see you next time.